Good morning to everyone. As part of our learning journey, Python learning journey, we are going to move towards our next step. When we want to use Python in automotive industry, we have to do certain periodic task when we try to simulate the vehicle network. This is very common. To do periodic task, why we need a periodic task? Because we used to transmit CAN messages periodically. There are certain CAN messages, those used to travel in the bus in a periodic manner. If that is the case, we should transmit them. There should be some task to transmit them periodically, right? Now that task should be run forever in a cyclic manner. Right. Till now, we had seen something like we have given certain inputs and then we generated some inputs, we printed like that only. We have done the programming in Python, but that is not enough. When you want to do a rapid prototyping using Python for automotive network, you have to do certain task periodically. Again, those that is more than one task should run periodically in a concurrent manner. That means both of them, more than one task should execute at the same time, because each module that we have in a vehicle network will be a program. When we try to simulate them, they are programs. In real times, those use will work in a concurrent manner. So we have to run our program also in parallel. That means we have to run concurrently. How to do that? So when we want to do more than one task at a time, in Python, we have something called threading. That means you can run multiple tasks at the same time using threading. Another one is to handle these delays, like time related functions. They have a time module. There are two modules available, threading and time. These two can be used to create periodic tasks in Python, which in turn will help us to build a prototype for automotive network. Right. So here is an problem statement that we are going to implement in Python today. This will be very basic steps when we learn vehicle network simulation right now. In case of CAPL, we have a timer functions right now. So we used to timer object type. So we used to declare timer using timer. We used to transmit them periodically. Otherwise, we use a DL, that is a interaction node layer and interaction layer DL will be used to transmit them periodically by configuring the database. That is one way. But how to achieve that in Python? That we are going to see. Here is a problem statement like print a CAN packet. So this is not transmit a CAN packet. We are going to do that after some time. We are going to transmit a CAN packet actually. But at present, we are going to print them. Print a CAN packet with the ID 123. That means the CAN packet ID should be 123 every 250 milliseconds in command line with all data content 0. Right. That is the first task that we have to do. After doing it, I can even add some more things to it. Feed data speed samples generated for vehicle speed signal to can signal vehicle speed. Right. Print CAN packet with an ID 123 every 250 millisecond command line with all data content 0. That is one thing. Change this vehicle speed signal of the packet. Otherwise, we can say change the vehicle speed signal of the packet by feeding every 1 second. So we have to transmit a CAN packet with the data content 0, right? And its ID should be 123, right? And it should have a signal called vehicle speed, right? Usually the vehicle speed can be represented in the 1 byte so that the DLC can be 1, and it should be transmitted every 250 milliseconds, or otherwise it should be printed on every 50 milliseconds. This is one task. Once this task is done, that means once this task is started, that means once it is running, once we get that CAN packet every 250 millisecond, we have to run another task. That task should change the vehicle speed signal every 1 second. What value to it should change? That we are generated right now. In the previous sessions, we explained how to generate the random sample for vehicle speed. Right. We generated those samples now. Those should be used to feed the vehicle speed every 1 second. So that is the task. But this is very basic task that every automotive project used to have, because every automotive project which uses CAN bus system right now. There will be a periodic messages which used to go outside. So it used to have a number of signal. So it will have a periodicity in which it used to go. And it used to have an identifier and then DLC defined everything. Right. So that is a periodic transmission. And again, we also did the programs in the past to feed the CAN signal transmitted periodically in the bus with some lookup table. For that, I have explained you in the previous session how to generate the samples vehicle speed. Those samples can be used to feed the vehicle speed signal every 1 second, one sample per second. Like that, we can fetch from it and can feed it. Right. That's how it works. So let us do the program now. To do that, what I have to do first, I have to bring Notepad++. Let me bring. And it is, we can say, message trans.py. As I told you before, we need two modules, right? We have to import them. I think totally 3 modules. Import threading, import time, import like random, because for random generation. Okay, after that, what we have to do? First thing that we have to do is we have to define a packet, CAN packet, right? So as the vehicle speed is involved, we can say like, we can call that packet as BCM info, because usually BCM used to transmit the vehicle speed. Then we are going to generate a dictionary for CAN packet. ID of the CAN packet as per the requirement is 123. and then channel this the first channel. Then we have DLC. It is only one because we are going to have only 1 byte in that packet. 1 byte in that only we are going to encode the vehicle speed. Then we have data, right? That is going to be a nested dictionary. Inside that we have a CAN signal vehicle speed, right? Which is initially having the value 0. Now we have a packet in our hand, right? The packet has been defined. Okay, what's the next thing? We have to generate the lookup table because we have to feed the vehicle speed signal, no? For that, we need a lookup table. Let us generate that speed samples. Initially, it is an empty list. Then index is equal to 0. Y index in range 0, 10. We are speed samples dot append random dot rand int 0, 250. So that means we used to have we are going to generate a random number in between 0 to 250, and we are going to populate that, add, otherwise append that to this speed sample list. When then we have to increase the index, right? So that we have 10 samples of vehicle speed, which is having different values, right? Okay, then what is next? The next is we have to create a task to transmit this CAN packet in a periodic manner. What is the periodicity of the packet that we have to define right now? So period 0.25, which is 250 millisecond. Then I come here. We have to create a task. The tasks are created in terms of functions in Python. To define a function, use the keyword def and then function name, right? Transmit message, right? So what this is going to do? This is going to transmit or print. Actually, in our case, it is print. We are going to print the BCM info. So print BCM underscore info, right? Okay, brilliant. After that, we have to create threads. This is the main thread. From here, we are going to create a separate thread because this should run independently, right? For that, threading dot timer, right? The period is that is a time period, that is periodicity of your task, right? And then we have to say target task name, which is transmit message, and then that's all. We have to start that thread. So this will be started and will run. So transmission of packet will be handled in a separate thread, right? Then that's all. But we need to update. Let us see first whether this is working. To check that, we have to call this in the main thread. Transmit MSG. Right? Does that make sense? Right. So now we have a can packet defined, period defined, and then a empty list created. Then the list is populated. Then we have a task to transmit this BCM info, and we are mapping it to a separate thread. So it will run independently, irrespective of main thread. Right. Cyclically, it will happen. Right. We are calling the whatever that we created, no, the task, the thread, the task is called here. Okay, now. So that's all. Let me check fast whether our whatever that I told is working. Right. So the name of the file is, name of the Python script is MSG trans, right? Python MSG trans.py. Okay, this is some issues because we missed the colon here, right? Interesting. Maybe I am using wrong. Data is not defined. Okay, brilliant. Right. So every 250 millisecond, I am getting a packet now. So it is printed on the screen. Maybe in future, we will be transmitting this in a message queue, so that other program, we will run multiple nodes. So one node will transmit the packet and another will fetch it and will use it, consume it. That we will do that in future. As of now, we are able to transmit the packet periodically using Python, right? It has an ID and channel, its DLC and data content, everything is going. We are able to see that in this command line. So now I want to terminate this one. The improvement that we want is, we want to change the vehicle speed signal that we have in the packet. Every 1 second, we want to change it. See, this packet is transmitted 250 millisecond once, but the vehicle speed should be changed in this packet. Vehicle speed signal that we have in this packet should be changed every 1 second. How to achieve it? In order to achieve it, so what we are going to do, we are going to start another thread. In this thread, to make the change, right? So first of all, I have to create a task which is going to change the vehicle speed. Def is a keyword and change vehicle speed, right? What this function going to do? This function going to change the BCM info dot data of data in that the signal vehicle speed. To that, we are going to give the value from the lookup table, speed samples, but we have to navigate every sample that we fetch from this list now, every time, every 1 second, we have to get a new sample from that list, right? To that, we need a rider. But the rider, we have to declare the rider somewhere. No, it should be declared globally because we are using it in between threads, main thread and subthread. So first of all, in order to make certain variable as a global to access everywhere, use a global keyword, and I call that as speed index. That means I'm going to use this to navigate the speed, and then I initialize that to 0. Right, billion. So now I am going to use that one here. For that, I have to say that the speed index is accessible here, that by making it global to this, right? Then I use that speed index, right? Okay, billion. But the speed index should be changed every time. Every 1 second, it should go to the next location, right? No? For that, speed index is equivalent to speed index plus 1, right? Sorry, speed index plus 1, but it should not exceed 10. For that, I put a modulo 10 so that it will always, it used to have 0 to 9, and then again it will come back to 0, like that it used to go, right? Okay, brilliant. Now we have the change vehicle speed. This task should be started in a separate thread when we transmit the message. Threading dot, it can be started anywhere, but in order to make it simple, we are starting it here. All right, then period. No, it's not period. It's every 1 second. No, so every 1 second, that task name is change vehicle speed, right? Then start. Makes sense, no? That's all. So now the vehicle speed signal, which is transmitted periodically by this thread, will be modified with a new speed value from the lookup table every 1 second by this thread, right? Let us see whether that is working. So let me kill that one. So now I am going to run it. See here, every 1 second, I am getting a new value from the lookup table, right? That's all. Now we are able to transmit the packets using Python from a file periodically, and then we are able to change the value of the packet, the value of a particular signal in the packet periodically. That is also possible. Okay, team, that's all for today. Let me catch you with additional detail in upcoming session. Thank you. Thank you for watching.